Hi, I'm Karsten, and my partner's Robbie with Physics 357, Project 1. We're doing a light detection circuit for eventually a sun tracker. So the premise of our project is we're going to be designing a motored device that will track the sun across the sky in order to optimize, say, a solar cell output or something like that. So our first thing that we need to accomplish is we need to detect some light and then track it. So the beginning of our circuit, we have two photoresistors and a simple voltage divider off of 9 volts. These two photoresistors provide variable voltage output depending on how much light is incident on them. When we initially started with those two photoresistors, we sent them into a 471 comparator. This comparator returns which photoresistor has more light incident on it. So if the left photoresistor in this case has more light, it returns a low value. And if the right photoresistor has more light, it returns a high value. So the difference in that voltage can tell us which side has more incident light. So we built that, and then we realized in our system, if we were going to actually hook this up to a motor, that means the motor would continually be fluctuating just due to ambient light differences. And so in order to reduce that fluctuation in our system, we need some sort of derivative control from systems analysis. So in order to do that, we set up a windowed comparator. So the first step in the windowed comparator is we need to take the difference of the two voltages. So we send, again, the voltages from the voltage dividers in the photoresistors into a 741 differencer circuit. And basically what this does is it differences the two voltages, so we get a difference. So we have a couple 100 k ohm resistors, send them into a 741, and we output the difference in the two voltages. So once we attain a difference of the two voltages, we're going to send them into a windowed comparator. We built this using a 1458 chip. The windowed comparator, it outputs a low value if the input, which would be this differencer input, is between two values. We set up a voltage divider here so that we could get half a volt on each side. So if the differencer returns a half volt on either side, the windowed comparator will return a low value. And if the differencer returns a value that's either above half a volt or below minus half a volt, it returns a high value. So you send that through an OR gate, and the OR gate basically checks to see if either one of those are true, and if it is, it returns high. If neither of them are true and it is within the half a volt window here, then we send it through a NOT gate and power an yellow LED, which tells us that the motor state would be to stop, to not move. That both the photoresistors have about the same amount of incident light, and that we don't need to move our tracking, our gimbaling. Now we bring back in the 741 to determine direction. That combined with the windowed comparator, we have a logic circuit here that basically chooses if the windowed comparator is true and this is outputting a high, then it's going to light a green LED indicating that it needs to go to the right. And if that is the right side has less sunlight on it, so that we need to tilt the gimbal to the right in order to get more incident sunlight. If it outputs a low and is in the is outside the differencer, then it outputs to a red LED. We turn that on, powering it with the 9 volts and a little voltage divider there, and we get that it needs to move to the left. So that's the overview of our block diagram of our project, and we'll go take it over the table and see how it works in practice.